Alright, Assalamualaikum. My name is Azim. I'm from class SL113-4A. Right now, I want to talk about mechanical base of human motion, which is chapter 6. Right now, there is 3 Newton's law, which is law of inertia, law of acceleration, and law of reaction. Right now, I want to talk about law of inertia. So, the definition of law of inertia is, so I will give you example. Like when you place a book on your desk, does the book move? Unless you have the book, it will remain where you put it without moving. So imagine like a spacecraft moving through space. When the engine are turned off, the spacecraft will coast through space at the same speed and in the same direction. Alright. The example for the book and the spacecraft have inertia. Inertia is the property of an object that resists changes in its motion. Because of inertia, an object at the rest tends to stay at rest. An object in motion tends to keep moving at a constant speed in a straight lines. Alright. Inertia explains how inertia affects moving and non-moving objects. Newton's first law states that an object will remain at rest or move at a constant speed in a straight line, unless it is acted on by an unbalanced force. And inertia comes from mass. Object with more mass have more inertia. It means when you have more mass, it will give you more inertia. Right. Cars and planes with more inertia take more force to accelerate. Since inertia is related to mass, in order to reduce inertia, you must reduce the mass. It means like when you want to reduce the inertia, you have to reduce the mass, because it's connect to the mass. The mass of a car or plane is a trade-off between inertia and the strength of material of the car or plane. The easiest example of inertia is like seatbelt of the car. Seatbelt of the car could be called anti-inertia, because a car tends to keep moving in a straight line, even if the driver's foot is not on the gas pedal. Everyone inside the car also have inertia. They are moving at the same speed as the car. So when the car is stopped, then you will feel the inertia of the car. Alright, right now I want to talk about the second Newton of law, which is law of acceleration. Alright, law of acceleration is Newton's second law of motion, which is when a body will accelerate with acceleration proportional to the force and inversely proportional to the mass is referred as law of acceleration. Right. A good example of law of acceleration is a car. For example, we are in a car and pushing down the gas or pedal, so we are in accelerating motion. When you apply the brakes of some period of the time, we are accelerating in the negative direction. So it means inversely proportional direction. Motion in a uniform circular is another example of acceleration where the acceleration applied is toward the center. Right. That's all from law of acceleration. Thank you. Alright, right now I want to talk about law of reaction, which is the third law of Newton, which is that it states that every applied force is accompanied by a reaction force, which is for every reaction there is an equal and opposite reaction. In terms of force, the law may be stated as when one body exert a force on a second, the second body exert a reaction force that is equal in magnitude and opposite in direction on the first body. So as you can see in the slide, a 90 kg rugby player collides with an 80 kg rugby player, right? If the first player exert a force of 450 and on the second player, how much force is exerted by the second player on the first? So according to Newton's law of motion, for every reaction there is an equal and opposite reaction, right? So for the solution on the sample problem is, if the force exerted by the first player on the second has a magnitude of 450 Newton and a positive but the first player is on positive direction, then the force exerted by the second player on the first has a magnitude of 450 Newton and a negative direction. So the second player is a negative direction. So the answer for the how much force is exerted by the second player on the first is for negative 450 Newton. Right. That's all for law of reaction. Alright, now I want to continue about the mechanical behavior of bodies in contact, which is have friction, momentum, impulse and impact. So right now I want to talk about friction. Alright, friction is force acting over the area of the contact between two surfaces in the direction opposite that of motion or motion tendency. Right, the magnitude of the generated friction force determine the relative ease or difficulty of motion for two objects in contact. Alright, for the example for the friction is when you put the box sitting on the level tabletop, the two force acting on the undisturbed box are its own weight and a reaction force applied of the table. Alright, the situation the reaction force is an equal magnitude and opposite in direction to the box weight. Alright. For the second example is like, as the magnitude of the applied force become greater and greater, the magnitude of the opposing friction force also increase to the certain critical point. Alright, at the point the friction force present is term called as maximum static friction, which is maximum amount of friction that can be generated between two static surface. So in the easiest way to understand is, there will be the box of on the top of table, it will a little bit move. That's we call maximum static friction. Alright, for the third example, which is once the box is in motion and opposing friction force continues to act, the friction present during motion is referred to as kinetic friction. That is what we call when your force is greater than the mass of the box, there will be called a kinetic friction. The box will move because of the force is more than the mass of the weight. Right. That's all for friction. Now we continue for the momentum. Alright. Right now I want to talk about the second of mechanical behavior of bodies in contact, which is momentum. Alright. Factor that affects the outcome of interaction between two bodies is called momentum. A mechanical quantity that is particularly important in situation-involved situation. Momentum can be defined generally as the quantity of motion that an object possesses. Linear momentum, which is called a quantity of motion, measured as the product of body mass and its velocity. For the formula for this momentum is m, which is momentum equal to mv, which is mass and velocity. Right. A static object which is zero velocity has no momentum. That is, if there is zero velocity, that means there will have no momentum. Right. For the example of the momentum is when head-on collision between two objects occurs, there is this tendency for both objects to continue moving in direction of motion originally possessed by an object which is the greatest momentum. Right. If a 90 kg hockey player travelling at 6 meter per second to right collides head on with a 80 kg, which is second player with 80 kg and travelling at 7 meter per second to the left. So since the second player have a momentum is greater, both player would tend continue moving in the direction second player original velocity after the collision. Alright. It's mean by even you have a good mass, like the first player 90 kg, but the first player have a lower meter per second, which is 6 meter per second, but the second player have a low mass, but he has a greater velocity, which is 7 meter per second. So in momentum, when we want to find the momentum, we have to see the velocity, which is when you have a good velocity, you have a good momentum. So in this case, the second player have the good momentum because of the greater velocity. Alright, that's all from momentum. Right now I want to talk about the third mechanical behavior, which is impulse. The impulse mean when an external force do act, they change the momentum present in system predictably. Changes in momentum also depend on the length of time over which force acts. For impulse means which is product of force and the time interval over which the force acts. Right. For the formula for the impulse is impulse equals to force times by time. When an impulse acts on a system, the result is a change in the system total momentum. The relationship between impulse and momentum is derived from the Newton's second law. Alright, which is F equal to ma, mass times by acceleration. Alright. For the example for the impulse is small force acting over large interval, which is a golf ball rolling across a green gradually loses momentum because its motion is constantly opposed by the force of rolling friction. This means by when you rolling a golf ball over the large time interval, the golf ball will gradually loses momentum because of the over large time interval. Right. For the second example, which is large force acting over a small time interval. For the easiest example for this is momentum of a ball the momentum of a baseball struck vigorously by a bat also changes because of the large force exerted by the bat during the fraction of a second it is in contact with the ball. Alright. That's all for impulse, and next will be the last mechanical behavior, which is impact. Alright, now I want to talk about the last mechanical behavior, which is impact. Alright, the impact is collision characterized by the exchange of a large force during a small time interval. Example type of collision that occurs between struck baseball and a bat. Right. There have two that can define the impact, which is perfectly elastic impact and perfect plastic impact. Alright, for the perfectly elastic impact is impact during which the velocity of the system is conserved. Example like impact of a tennis ball with a hard surface approaches perfectly elasticity because the ball speed diminish little during its collision with the surface. Right, that is the example for the perfect elastic impact. And for the perfect plastic impact is impact resulting in the total loss of system velocity, which it means the zero after impact. There is no impact there is no bouncing after the impact. Right. For the example for the perfect plastic impact is during which at least one of the bodies in contact deforms and does not regain in its original shape, and the bodies does not separate. Like this occur when you drop the modeling clay on the surface. There is no bouncing and the bodies does not separate, and it's in original shape because of the modeling clay have no, there is total loss of system velocity. Alright, that's all from me. Thank you.